This is lesson U1A06c. Hopefully by the end of the lesson, you should be able to say I can solve angle relationships formed between parallel lines and transversals. So this is actually a continuation from the previous two lessons, which are on angles formed between parallel lines and cut by a transversal. However, the example that we're going to look at here is going to be a little more challenging, which will require you to think outside the box just slightly. Okay, I want to introduce another tool to you guys. In addition to drawing all over the diagram, there's something else that can also be helpful and serve to your advantage, okay, at some point whenever you're problem solving. All right, so pause the video for a moment, take and digest this problem that is presented right now. See if you can make heads or tails with this, okay, and then we'll regroup. So hopefully by now you thought of the problem a little bit, okay? And the goal is to find out what x is here, okay? And you're told that there are two lines, L1 and L2 is parallel, and then we have these two other lines, okay, that are transversals, okay, that don't quite intersect, but are drawn as line segments, okay, where those transversals are intersecting and touching, okay? And I'm telling you that the angle formed in the middle there, that major arc there is at 280 degrees. So by inspection right now, can we say that x plus 10 and angle x, so I am referring to these two angles over here, can we refer to them as consecutive interior? And actually that's actually a common misconception. These two angles are not consecutive interior. However, I will agree that they are on the interior of the two parallel lines, but they are not consecutive interior angles because we're dealing with two different transversals here. And because of this, okay, the concepts that we had talked about in the previous two lessons is not applicable. How can we manipulate the situation so that we can apply the concepts from the previous two lessons then? That's the question, okay? In life, whenever you are presented with something that you are unclear with, the thing to do is to make that situation that you're observing relatable, okay, and recognizable. And then from there, you can make other inferences. So what I'm going to try and do is I'm going to manipulate the situation in such a way where it really doesn't change the situation. However, what I'm adding to this, okay, will serve to my advantage. So what exactly is that? How does that look? What I can do is I can draw a line passing through that vertex, and that line that I draw, okay, what I'm doing is I am putting in place axiom number 5 from the geometry axioms that I introduced 3-4 lessons ago, right? I'm drawing a line such that this line is going to be parallel to both of the existing line in the problem. Have I changed anything to the original problem? Not really. I've just augmented it. I've put in something else that's not a part of the problem. However, this is to serve to my advantage. So how does that serve my advantage? Well, if I put in this third line, this is what we call often in mathematics, this is an auxiliary, okay? This is an auxiliary. And what exactly is an auxiliary line? An auxiliary line is, it's a line that's not part of the original problem, okay? So that's what it means for it to be an auxiliary line. And this auxiliary line, I am going to make it parallel to the two existing lines that are present. So if I do this, okay, then what happens is, let's say if I call this line 3 and I call this line 4, line 3 and line 4, okay, are actually now going to be transversals, okay? Line 3 is going to be transversal between line 1 and line 5. Line 4 is the transversal for line 2 and line 5. So now what I can do is I can implement all the concepts, okay, that were from the previous 2 to 3 lessons. So knowing this now, okay, this angle over here, okay, and this angle over here must be congruent because they are on alternate sides of a transversal, And we know that alternate interior angles, because they're in between the two parallel lines there, are supposed to be congruent. So therefore, the two angles that are in pink, they will be the same. That's x plus 10 over here. And then the two angles on the bottom, okay, over here, which I'm highlighting in blue, they too are alternate interior angles. Those interior angles will measure x apiece. And we're almost done. So what I'm highlighting right now in green, okay, all of this, okay, that whole angle there, okay, those are explementary angles. If I were to combine 280 with the x plus 10 and the x, we recognize that all three of those angles should add up to 360. So that's the quote-unquote trick, okay? So here we have 280 plus x plus 10 plus x is equal to 360. And now this now is turned into an algebra problem and not a geometric problem. So now I'm going to combine all the like terms. I have 2x plus 290 is equal to 360. Subtract both sides by 290. I end up with 2x is equal to 70. Or x is simply equal to 35 by dividing both sides by 2. And there you have it.